Hi, Assalamualaikum. I am Afika Rahani. The title for our mini project hydraulic is Properties of Fluid. For the introduction, the three parameters that we would like to highlight in this experiment are density, viscosity, and capillarity. To demonstrate these properties, we will be using three types of different fluid, which are water, cooking oil, and dishwashing liquid. The objective of these properties of fluid, the first one is to determine and understand various physical properties of fluid. And the next one, the second one was to measure properties such as density, viscosity, and capillarity, and how does the different type of fluid that we use affect the properties. The problem statement that we can conclude in this project is this experiment aims to provide hands-on experience in determining the density of different fluid, measuring their viscosity, and observing capillarity effects in small tubes. By conducting this test, students can deepen their understanding of how fluid properties influence real-world engineering applications. I would like to explain the type of properties that we would like to highlight in this experiment. The first one was density. Density, as all we know, density is the mass per unit volume of a fluid. So in this experiment, we will use three types of different of fluid, which are water, cooking oil, and dishwashing liquid. And we will measure and determine the calculation and density of the fluid itself. Next is viscosity. Viscosity experiment is to measure how thick or sticky a fluid is. In other words, it's resistant to flow. So in this experiment, we will use a stop close method or falling ball method, which is we will take and measure the time taken of the ball to fall from through the fluid, and measure how does the viscosity affect the fluid. How does the fluid affect the viscosity? And last but not least is capillarity, which is a fluid's ability to move through narrow spaces. In this experiment, we will use three types of different sizes of straw to measure the fluid's ability to move and the height of the straw in the fluid itself.
Hello, hi, I'm Nabila. Today I want to do an experiment on how to determine the density in fluid properties. First of all, you need soap, cooking oil, and butter. So, first step is you need to weigh this empty beaker to take a mass of beaker. Okay, next I want to do a demonstration on how to determine density in fluid properties. First of all, you need to fill in 200 ml of water. And then add on soap for 50 ml. And 50 ml of water. Okay, next we wait for 50 minutes. Okay, next after 50 minutes, we can see the soap has a higher density at the bottom of beaker and the oil at the top of beaker. You can test the density between marble and bottle cap. First of all, put a marble and then bottle cap inside the liquid. And as we can see now, the bottle cap has a lower density than a marble. Overall, the experiment helped enhance our practical skills in measurement and our theoretical understanding of fluid behavior, especially in relation to how density influence layers, mixing, and flow properties of fluid.
My name is Afika Rahani. Today I will be presenting our lab experiment on determining the viscosity of the fluid using stop loss, which is known as the falling ball method. The tools that we use are vernier caliper to measure the radius of the ball bearing that we use. Next is transparent cylinder to fill up our fluid, the dishwashing liquid, the oil, water, and also stopwatch to
to measure the time taken of the ball to fall from our two fixed point.
First step, we must measure the weight of the ball bearing and also the radius of the ball bearing using vernier caliper.
Next, we fill up our cylinder with 150 ml of water. Next, we measure the time taken of the ball falling from the first point to the second point. Next step, for the dishwashing liquid, we also use 150 ml and fill up the transparent cylinder. Next, for the cooking oil, we fill up the beaker with 150 ml and measure the time taken of the ball falling from the first point to the second point.
For the result and analysis of this viscosity experiment, first we have to measure and determine the radius ball bearing and also the density of the ball bearing. As we can see in this slide, the ball bearing radius that we had is 0.00275 meter and the density that we get is 1,309 kg per meter cube. After that, we will measure the time taken of the ball to fall through the fluid in the cylinder for 3 times or 3 readings. After that, we will average all the readings, and as you can see in the table 3, we conclude the average time, and after that, we can calculate our viscosity and also density of the fluid. The formula of viscosity that we use is 2 per 9 times R squared times density of the solid minus with density of the fluid times with gravity and divide with velocity. To conclude this experiment using Stokes-Close method, successfully determined the viscosity of tray fluid. Dishwashing liquid recorded the highest viscosity at 1.902 pascal second, followed by the water at 0.293 pascal second, and cooking oil with the lowest at 0.189 pascal second. The result clearly show that the thicker the fluid, the slower the ball to fall, and the higher the viscosity. This proved the inverse relationship between terminal velocity and fluid resistance.
Hello everyone, my name is Ainu Shafika. Today, I would like to share with you an experiment that will determine one of the properties of fluid, which is capillarity. Capillarity is a tendency of a liquid in a capillary tube to rise and fall as a result of surface tension. The objective of this experiment is to describe how capillarity occurs with different diameter with contact with water. Here, I will begin the capillarity experiment using 3 straws to replace capillary tube that have same length but different diameter. First of all, fill in the beaker with water. Then, put the 3 straws in the beaker without touching the bottom. Stay like that for 30 seconds. Repeat the experiment using another liquid, which is dish soap. Repeat the experiment again using oil. As you can see, the narrowest straw have the highest water level in it.
So discussion for the experiment is the experiment successfully demonstrate the core fluid properties, which is density, viscosity and capillarity, and their effect on fluid behavior. For the density test, fluid like water, oil and soap solution were measured and compared. As expected, water had the higher density than oil but lower soap solution. In the viscosity experiment, the resistance to flow was clearly observed. Oil show a higher viscosity compared to water, flowing more slowly through the viscometer. The capillarity test illustrated how fluid rises or fall in a narrow tube due to surface tension and adhesive forces. Overall, the experiment enhanced the understanding of fluid behavior under different conditions. The results were consistent with theoretical expectation and highlight the importance of fluid properties in engineering design and everyday phenomena.
In conclusion, this lab experiment showed the relationship between density, viscosity and capillarity. In liquid, higher density leads to increased viscosity, which affects fluid flow behavior. As the density of the liquid increases, the height to which it can rise in a capillary tube decreases due to the stronger gravitational pull opposing capillary action. Overall, the experiment clearly shows how fluid properties and forces related to influence capillary rise, a key concept in both physics and hydraulics.